Hello students, today I am going to discuss exercise 1.4 and question number 1. In this question, without actually performing the long division method, we have to find out whether given fractions is so terminating decimal expansion or non-terminating but repeating decimal expansion. For this, we have to take the denominators and get the factorization. If it contains only 2 and 5, 2 and 5 or 2 or 5, then it will show terminating decimal expansion. But if it show or contain other prime numbers like 3 or 7 or 11, then it will show non-terminating but repeating decimal expansion. Okay, now I'm applying this concept and show you how you will solve the questions. For this, I am solving 3, 1, 2, 5. You take 5, 6 to 5, 5, 1 to 5, 5, 25, again 5, and 5, and again 5. You can see it contains only 5 and 5 and 5. It means this is terminating. As I told you, if the denominator contains the factors in 5 or 2, then it will show terminating decimal expansion. If it contains other than 2 or 5 and 5, then it will show non-terminating but repeating decimal expansion. You watch 8. We can factorize 8 like this: 4, 2, and 2. It shows only 2, so terminating. Now come to this 4, 5, 5 with 5, 91. This contains 7 and 13 other than 2 and 5. So this will show non-terminating. Okay, non-terminating. For this, you can check 1600. You check. Write down here 1600. 2, 800. For 2, 400. 2, 200. 200. 250. 225. Now you know that 5 and 5. Okay. The factorization of 1600 contains only 2, 2 and 5. Means this will show terminating decimal expansion. Now come to here 343. This is the factorization of 7 to 7 to 7. Non-terminating. Here factors is already given 2 and 5, terminating. Here the factor is given, here 7 is present, so you know the rule, non-terminating, as I told you. Here first of all come to the simplest form, 2 and 5. The factor contains 5, denominator contains 5. You know this is terminating. Here come to the 5, 7, here 10. You know the factor of 10, 2 into 5, terminating. Okay, now you come to the simplest form, 11, and this is 30. You know the factor of 30. In spite of that, I am doing 2, 15, 3, 5 and 5. This contains 3 other than 2 and 5, non-terminating. I hope you understand this question very clearly. Now come to the question number 2. In this, write down the decimal expansion of those rational numbers in question number 1 above which have terminating decimal expansion. These are the terminating decimal fractions as I discussed in question number 1. So we convert this into decimal form. How we convert? Like this: 13. Now you write down like this: 5, 5, 5, and again 25, 125, 625, and one more 5. Okay. I apply the concept. I make this into 10. Like this. If I multiply this by 2 and 5 into 2, 10. Here 5 times 5%. It means I multiply this denominator by 2 5 times. Okay. As I multiply 2 here in denominator, so I should multiply this in above also. Means in numerator. Okay. This will come 5 into 2, 10. 5 into 10, 10, 10, and 10, and 10. Okay. And this 32. 32 into 30. Now you multiply, you will get 1, 2, 3, 4, 5. And 13 to is 26. And 13 3 is 39. 39 and plus 2, 41. Now you write down like this: 4, 1, 6, 2 times 0, decimal 0. You will get this decimal form. Now come to the second part. Write down again in the same way. Here factorize the 8 into prime factor. You will get 2 here. Now you multiply with 5 to make 10 in denominator. In the same way, you multiply 5 here also, so that this become equivalent fraction. Now multiply. 125 into 17, and this 10 into 10 into 10. Now 17 5 is 85, 8. 17 2 is 34, 34 and 8, 42, 4, and 17 1 is 17 and 4, 21, and here 1000. You will get 2.125. Okay. Now come to here. Similarly, 15. Okay. Now do the factor. 2 into 2 into 2 into 2. This becomes 16. And 400, 2, 5, 5. This is already 100. You have to convert this into. So for that you have to multiply 4 times 5. Here also. Sorry. 5. what you will get? Into 100. For this, 5 times 5, 625 into 15. Now you multiply. 15 5 plus 75, 7, 33 and 15, 6 ja 150 and 3. And here 1, 2, 3 and like this, and put the decimal after 6 digit. 5, 7, 3. 5, 7, 3, 5, 1, 0, this. Okay. For this, here is only 1 5. You multiply here 2 to the power 3 and here 5 to the power 2. You multiply this by 5 and here also 5. 15 and 10, 11. And for this, what you will get? Okay, I hope you understand me. 3, 2 and 5. 2 upon 5. You multiply 2 with 2 here and also here. What you will get? 4 upon 10. Answer 0.4. For this, first of all you cut. What you will get? 7 upon 10. And answer is 0.7. I hope you understand this also. Dear student, thank you. Thank you for correcting me. I commit mistake here. Very good. You told me I am very much impressed with you. Not 15 here. I should put 9 here. 9. And for this, you put this 9. 9 and put 0. Very good. You are sitting attentively in the class. Very good. Hello friends. Now come to the question number 3. In this question, we have to tell whether they are rational or irrational. As this decimal expansion show terminating decimal expansion. Terminating decimal expansion come into the category of rational number. Rational number. And this shows non-terminating but repeating. This category also come under the rational number. Rational number. Non-terminating but repeating. And this case is non-terminating and non-repeating. This come under the category of irrational number. Irrational number. Again, if they are rational of the form P upon Q, what can you say about the prime factor of Q? As this shows the terminating decimal expansion. So, in this case, Q must contain factors either in 2 or 5, because this shows terminating decimal expansion. So Q must contain factors either in 2 or 5. Now this is non-terminating but repeating. In this case, Q must contain factors. Factor means prime factor. When I say factor, it means prime factor. You must contain prime factors other than 2 or 5. You must contain prime factors other than 2 or 5. Means it may contain 7 or 3 or 11 as a factor in denominator. That's why. Okay.